हाय कुलदीप। हाय कुलदीप, हाय श्रीशा। How are you?
गुड इवनिंग सर।
Good evening, good evening।
गुड
और
इवनिंग सर। सर वो समझा दो एक बार, केसेस वाला मुझे
so
कोड में मिल तो गया पर्चा, लेकिन फिर भी थोड़ा सा आप
I
एक
will tell
बार।
you this. Wait a moment. Let me open the code. I think I have already explained to you. Let me. मैंने शायद तुम्हें दिखाया भी था कैसे कंसीडर करते हैं, तुम ध्यान नहीं दिया होगा उस टाइम में। एक
क्या
मिनट।
सर?
लोड कॉम्बिनेशन पूछ रहे हो ना तुम?
हाँ वो सर ऐसा ही नहीं, वो मैंने कोड में ढूंढा था, मुझे मिल तो गया कोड में। और जैसे इसमें ना एक्सीडेंटल केस और वो भी डाल रखे, तो उनको कब कंसीडर करना है, उसमें कंफ्यूज
एक्सीडेंटल
हो रहा
केस
हूँ।
सब कंसीडर होता है अगर तुम एक्सीडेंटल लोड अप्लाई करोगे। अगर तुम्हारा ब्रिज एक्सीडेंटल एरिया में नहीं आ रहा, जैसे जितने भी ब्रिज ऐसे होते हैं जो जैसे रेलवे ब्रिज हो गए, वो कभी एक्सीडेंटल एरिया में नहीं आते। या तुम्हारे इसके हो गए हिल एरियाज में जितने भी ब्रिज होते हैं वो भी एक्सीडेंटल एरिया में नहीं आते। एक्सीडेंटल एरिया में वो ब्रिज आते हैं जिनके जिनसे हमारी गाड़ी टकरा सकती है, या तो हम कम हाइट पे ब्रिज बनाते हैं या कलवर्ट्स बनाते हैं, उसमें हम अज्यूम करते हैं कि क्या पता व्हीकल आके टकरा जाए, तब आता
ठीक
है
है।
एक्सीडेंटल। वरना एक्सीडेंटल की जरूरत नहीं। लेट मी शेयर टू माय स्क्रीन।
तो
तो
जैसे इसमें ना कोड में 7 पॉइंट जो कॉम्बिनेशन है अपना, 7 नंबर आर्टिकल है
एक मिनट
IRC
रुको,
6 के
मैं
अंदर।
कोड ओपन कर रहा हूँ, तुम मुझे बताओ क्या
ठीक।
क्या कंफ्यूजन है। ठीक।
तो जैसे IRC 6 में अपने एक दे रखे हैं ना, रेयर
हाँ,
कॉम्बिनेशन, फ्रीक्वेंस कॉम्बिनेशन, क्वेसी पैरामीटर,
वो तो
कॉम्बिनेशन ऑफ
सर्विस के हैं।
डिजाइन।
हाँ, सर्विस में कहूँ, अभी बात हमारी तो इसमें चल रही थी ना तुम्हारी, लीडिंग और एकम्पनिंग में।
तो जैसे इसमें जो कॉलम दिया है वही कॉलम कंसिडर करना है ना उसके अंदर।
हाँ हाँ, उस वही करना होता है। अब देखो इसमें ये कॉलम है, ठीक है।
हाँ सर।
ये एक कॉलम हो गया, ठीक है। अब तुम इसके लिए डिजाइन करना चाहते हो, तो यहाँ पे लिखा
ये।
हुआ है लीडिंग और एकम्पनिंग, ठीक है। एक बार
हाँ
तुम
सर।
1.5 कंसीडर करोगे, फिर बाद के 0.9 कंसीडर करोगे और 0.9 कंसीडर करोगे। फिर इसको
ठीक है।
वो कर दोगे, एक कॉम्बिनेशन बन गया। दूसरे कॉम्बिनेशन में क्या करोगे, ये वाला 1.5 कंसीडर करोगे, इसका 1.15 कंसीडर करोगे, इसका 0.9 कंसीडर करोगे। फिर ये
अच्छा।
खत्म कर दोगे, फिर इसका 1.5 कंसीडर करोगे, फिर इसका 0.9 कंसीडर करोगे और इसका 1.5 कंसीडर करोगे। तो एक कॉलम के तीन बन जाते हैं। ऐसे ही इसमें भी बनेंगे एक कॉलम के तीन,
ठीक है
जब वो
सर।
लीडिंग
जैसे
होगा।
ये
हाँ मतलब बताओ ना।
तो जैसे अपने इसमें दे रखा है क्वेसी पैरामीटर के लिए B3 टेबल का कॉलम नंबर फॉलो करना है। तो
कौन सा
B3
क्वासी
टेबल का।
परमानेंट? ये।
हाँ। तो उसमें अपने
हाँ,
को
तो
सिर्फ
बस
यही
इसमें
करना
यही
पड़ेगा।
यही करना, बस इसमें कुछ वो नहीं होता, इसमें लीडिंग कुछ नहीं आता। क्वासी परमानेंट से परमानेंट लोड के लिए होता है, उसके नाम में ही परमानेंट है। तो इसमें ना वेरिएबल लोड आते ही नहीं है, सिर्फ वेरिएबल के नाम पे एक ही लोड आता है, ये, वो भी थर्मल लोड। कोई भी नहीं आता ना इसमें, लाइव लोड आता है ना तुम्हारा विंड लोड आता है, सिर्फ एक थर्मल लोड है। तो इसमें कॉम्बिनेशन एक ही बनता है बस।
ठीक 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 सर।
इसके कॉम्बिनेशन अलग बनेंगे क्योंकि इसमें फिर लीडिंग आ गया, फिर वो आ गया। इसमें भी बनेंगे तीन तीन, फिर इसमें लीडिंग आ गया, फिर कंपनी आ गया। कॉसी
तो
परमानेंट में नहीं आता लीडिंग कुछ भी। इसमें बस
फ्रीक्वेंट
ये।
कॉम्बिनेशन, फ्रीक्वेंट
हाँ,
कॉम्बिनेशन डायनेमिक एनालिसिस लिए करते हैं
कौन से? फ्रीक्वेंट?
ये।
फ्रीक्वेंट तो
हाँ
करना ही करना है। फ्रीक्वेंट फ्रीक्वेंट से क्या मिलता है हमें? डिफ्लेक्शन मिलता है। इफ यू वांट टू चेक your bridge for deflection, then you need to consider friction. And if you want to check the stresses, you need to consider rear. And if you want to check the crack width, then for quasi permanent. Different load combination will give different values. It's
ओके
not
ओके।
like that कि तुम्हें एनालिसिस से कोई लेना देना नहीं, चेक से लेना देना होता है। एनालिसिस तो
अच्छा
तुम
इसमें
नॉर्मल कर दो, कुछ क्या फर्क पड़ रहा
एक साइड में स्ट्रक्चर के लिए अलग दे रखा है, बेरिंग के लिए अलग दे रखा है, तो ये अपन को
है?
बेरिंग के लिए वापस लोड कॉम्बिनेशन निकाल के वो रिएक्शन निकालनी पड़ेगी
बेरिंग
क्या?
के जो कॉम्बिनेशन है वो यही है। बेरिंग के लिए तुम्हें कोई अलग से नहीं करना।
अच्छा
तुम
अच्छा।
इन्हीं कॉम्बिनेशन से बेयरिंग के रिएक्शन निकाल के दे सकते हो। बेयरिंग के टेबल बनती है, उसमें तुम्हें सर्विसिबिलिटी के रिएक्शन देने पड़ेंगे, स्ट्रेंथ के रिएक्शन देने पड़ेंगे और सीज्मिक के रिएक्शन देने पड़ेंगे, और साथ में साथ रोटेशन भी देनी पड़ेगी।
ठीक है सर।
मैंने अभी बनाई भी थी, अभी पिछले वीक ही, पता नहीं कहाँ रख दी होगी, वो मुझे ध्यान नहीं।
और सेम फॉर फाउंडेशन वाले के लिए भी यही होगा फिर? बेस
ये
प्रेशर डिजाइन फाउंडेशन के लिए
बेस
B4
प्रेशर
नंबर
के लिए
चाहिए।
डिफरेंट होते हैं, बेस प्रेशर के ऊपर है कॉम्बिनेशन।
नीचे
ये
वाले
है वो।
B4 है सर, B4।
अब मुझे ऊपर स्टेबिलिटी गए, फिर पहले तो स्टेबिलिटी चेक करोगे। ये अगर तुम्हें स्टेबिलिटी आ जाएगी तब जाके बेस प्रेशर भी उसमें ही आता है। ये देखो, पार्शियल सेफ्टी फैक्टर फॉर इक्विलिब्रियम। अगर तुम्हारी ओपन फाउंडेशन है तो पहले उसका वो भी तो देखोगे, इक्विलिब्रियम।
हाँ हाँ, तो
तो
पहले
ये भी
अपन
तो,
इक्विलिब्रियम में स्टेबिलिटी में चेक कर लेंगे, ओके है
हाँ,
कि नहीं है।
उसके बाद तुम
उसके बाद
जाओगे बेस
डिजाइनिंग के
प्रेशर।
लिए जब अपन लेंगे
नहीं
तो
नहीं,
वो वाला चेक
बेस
कर लेंगे।
प्रेशर। हाँ, फिर उसके बाद उसमें जाओगे डिजाइनिंग। ये है बेस प्रेशर का। ये
अच्छा
तो
अच्छा अच्छा।
बेस प्रेशर भी तुम्हारा एक तरीके का यही है चेक, क्या नाम है उसे, स्टेबिलिटी चेक ही बोलते हैं।
हम्म।
क्योंकि वो उससे ही तुम्हारा साइज डिपेंड करता है। बेस प्रेशर स्टेबिलिटी चेक का मतलब ये होता है साइज इन विच अवर स्ट्रक्चर साइज डिपेंड्स। अगर हमारा, क्योंकि इसमें क्या होता है, इसमें रीइंफोर्समेंट भी आएगा इन दोनों में, सर्विसिबिलिटी और अल्टीमेट में। लेकिन तुम्हारा बेस प्रेशर और अपने स्टेबिलिटी चेक में कभी भी रीइंफोर्समेंट इन्वॉल्व नहीं होगा। सिर्फ तुम्हारी जो साइज ऑफ फुटिंग है या साइज ऑफ रिटेनिंग वॉल है, सिर्फ वही इन्वॉल्व होती है। और ये सिर्फ सिर्फ इन्हीं कुछ चीजों के लिए यूज होते हैं, एक तो रिटेनिंग वॉल, एक कलवर्ट, और एक ओपन फाउंडेशन। या पाइल्स आ गए तो अपने बस पाइल कैपेसिटी चेक होती है। बाकी कहीं और सुपर स्ट्रक्चर में यूज नहीं होते इक्विलिब्रियम वाले, या फिर बेस प्रेशर वाले पियर में कहीं नहीं यूज नहीं होते, फाइल कैप में यूज नहीं होंगे, और कहीं जरूरत नहीं पड़ती। बस ये तीन तीन चार स्ट्रक्चर ही होते हैं जिसके अंदर इसकी जरूरत पड़ेगी। अगर तुम्हें कलवर्ट डिजाइन करनी है, बॉक्स कलवर्ट, पाइप कलवर्ट, एनी काइंड ऑफ कलवर्ट, और फिर तुम्हें अबटमेंट डिजाइन करनी है, या फिर तुम्हें ओपन फाउंडेशन करनी है, या रिटेनिंग वॉल करनी है, इतने से ही आते हैं। या वेल होता है, वेल तो मिलेगा नहीं इनके लिए। वेल क्या होते हैं, बस एक वेल के इंपॉर्टेंट होते हैं इक्विलिब्रियम के कॉम्बिनेशन ज्यादा, तो वो उसमें आता है।
ठीक, ओके सर। ठीक है सर, थैंक यू।
ठीक है। और कोई डाउट हो तो पूछ सकते हो, इसमें अभी खुला ओपन ही है कोड। अगर तुमने
अच्छा, वो है क्या, उसमें लेक्चर निकल गया, अभी डिजाइन कर रहा हूँ, एक बॉक्स कन्वर्ट भी कर रहा हूँ और
हाँ,
आपके
ओके
वाला
ओके।
भी है, वो भी है। तो
हाँ, इसके बाद कोई इशू नहीं, कोई नहीं।
स्टार्ट कर रहे हैं
मतलब
तो फिर
लेक्चर,
लोडिंग लेवल पे मैं थोड़ा वही रखता हूँ।
नो इशू। कंफ्यूजन, जब तक तुम खुद से टेबल नहीं बनाओगे अपनी लोडिंग की, कंफ्यूजन रहेगा
हाँ वही सर, वही।
ही। तो वही रहता है हमेशा,
ओके ठीक।
खुद से वो दिक्कत आती ही है। कोई नहीं, अभी हम डिस्कस करते हैं। हाँ,
थैंक यू सर।
no issue, no issue. So this we have completed. Now we are discussing about the steel gutter in which we have designed the bracings, and now we are going to design our PC, this steel composite. I think previously we are looking. Let me see. I have checked it. Should not give me any other thing. I will check again this thing. Effective fit. So I was trying to do it as per code IRC 112. I will show you what is meant by this. Also. But it is still coming empty. Now I will go into boundary, effective fit. And from this also, and if I click this thing, okay, if I go back here, I have, okay, that is the thing. Okay, wait a moment. I have considered this one. So that is why it is given problem. Let me delete and delete it because I will show you code what I mean by this. If you go into IRC 112 and just go the initial pages. There will be effective width calculation. I will go to last step. First of all, the classification. These are the classification. This is B effective width of concrete slab. So it totally depend on for inner beam, it will be L0 by 4 should be less than B1 plus B2 upon 2. And if B1, B2, then B it will become an L0 by 4. L0 mean span. Now our span is 36 meter. So what will be there? Like for shorter span, our effective width changes. But for higher one, like 36 divided by 4, we get 9 meter, which is pretty much high. So we need to consider the same width, whatever we are getting. Like C at this combination. So B1 is like from one spacing to another spacing. B2 is another spacing. So that I'm trying to assign to it the same thing. So that is
For outer girder, it will be different, no, sir. For inner girder,
outer girder, what will happen? Even outer girder have been mentioned. For outer girder, L0 plus L0 upon 8 plus X upon less than B1 plus X upon 2. So what you will need? We required X, this. And this X equal to B0. Nothing should be less than L0 upon 8. So what is our L0? L0 again 36 plus divided by 8, 4.5 is still greater than, and our B1 and B2 is 2.5. So even if you consider the effective width factor 1, it will give you accurate result. So this is very important for shorter span. But if your span is longer, your effective width will be the same, whatever the spacing between the girder will come, or in this B0 plus B1 will come. Like half of B1 upon 2, and this X or X is nothing, B0. You're getting this?
cantilever distance, no, sir.
This is a cantilever. In cantilever, it is different. Generally, you will not found cantilever steel bridges. You will found continuous bridges. In continuous bridges, our L0 changes. L0 is the contraflexure, one contraflexure point to another contraflexure point. Like where your moment becomes 0. From one moment 0 to here also they have shown the diagram also. Or you can consider for continuous span, like if you have this kind of a span, so we can consider 0.8 L1 because at this position my moment will change. From negative it will become positive, and from top it is considering 0.255% extra, 0.25 of L1 plus L2. So whatever the maximum, we will take the effective length.
Ours is
L0.
simply supported, no, sir.
Ours is simply, but still I am telling you about if you got anything in future regarding the continuous girders or continuous steel bridges. So this we need to follow. And that's what I try to.
Supported, we will consider cantilever itself as L0. But here it will be different, no, sir.
No, here why should be different? Same is there, no? This is a cantilever, no? This portion. So
cantilever
here
is nothing but the B0, no?
B0 plus B1, half of B1 by 2. Here it is
that
mentioned,
is what normal. Usually, how we used to do effective with same thing, no, sir.
Like
for
it will
inner girders,
affect
it is girders.
if your bridge span will be less than 20 meter or 25 meter or 18 meter, 15 meter, then it will go into effect. Because then your L0 will be less.
Yes.
So that's why this condition only activates when your span length is less as compared to your this spacing of girders.
Okay. Then for continuous girders, it will be totally different. Moment based on the contraflexure points we have to decide.
Yes. For continuous is to do, and that is what I'm trying to do here. So
this in boundary, it is there, sir, effective with.
Yes.
In boundary, effective
it is there, but it is not taking. That is why I want to know why it is not taken. Because like this, this is I have already given to it I j maybe let me see that. This is fine. This is also fine. Should I include? So here is my bearing. Should I give the full one? Maybe I will delete and create again. No. There should be one should come. That is only concern. Okay. Even if I it will look like this. 1 1 1 1 1 1. Now it has been provided. Okay. We'll design the same. Well, designing this is the governing girder will be there, and if you go into the results, I need to again run it. Design, compose it.
How, sir, it has taken the effect with us, sir?
So I have taken by this. There is two methods you can apply. If you go by if this is not taking because it's not affecting, then you can go into boundary tab. There is also mentioned effective width. Click on this. It will ask you the scale parameter. So all scale parameter are 1 1 because my effective width is not decreasing. So I will consider the select girder and I can click apply, and you can see by this these are the all. So that's how you can able to consider also.
For our whatever the girder we are designing, for that it is we have
Yes.
considered.
Yes. Now we need to go in the design.
What
Lot
is
of
the meaning
things.
of this one, sir? One means it
One
is
means like whatever width we have already provided 2.5, it will consider 2.5.
same thing.
Yes, same
If
thing.
by calculating the formula, if we are getting something else, then we have to change the
Yes,
factor.
yes. Then we have to change the factor. That is the thing. It is important thing in your design. If you not able to consider the full effective width, then what is the benefit of steel design? We need to consider that. So and small bridges we need to reduce that for a smaller span. And yes, in design part, I think we have already seen this thing, but not seen this. So design parameter already shown you this kind of parameter directly. Everything is code based. These all checks we required. So we click OK, nothing else. Then and again design material. In design material again, I think previously also show you RCC will be M40. I'd see this fine close. Then longitudinal reinforcement we already provided it. If you remember it here. Then you have design position. Now this is important like L by 2. If you remember previously, I have also done this thing. So like if I'm selecting, maybe I will show you the result first. Now for this, I need to rerun the model, or I can just directly select what is the in between query. Like this is my, this to this point is giving around 35 point something. So it will be 36, 18. So here how much? 16, 19. So this I will select. $14 number. Okay. And just click I and J both position. Click apply. Then again in result, not result, design. Design output. Again, my element was 14. I and J. Apply. Now shear connector. Now this is the important one. I think people little bit have knowledge, but a shear connector I will show you. And you can use directly code IRC22 for this thing also. There is shear connector. Directly everything was given. If you need to calculate, you can also design for 30. Shear connector. If you come into
For fatigue limit, we have to use that fatigue vehicle, sir.
fatigue is not just a range, nothing else. Or generally, fatigue is generally do for this weld connection or how you're joining the girders generally. But it generally does not give you anything because this is an extra check. It is required for repetitive cycles. So you got a stress range according to fatigue vehicle in this range. There's some range have been given. So if we got less than that, that is fine. I'll show you. Wait a moment. Let me first discuss about this shear connector. So in shear connector, we have two kind of connector. First of all, generally stud, and the old which are people was using the channel connector, but we are using right now stud one.
How it will
So
look like, sir? Stud means?
You have seen ISMC. Maybe I will show you ISMC steel sections. Where is
channel?
Channel. This kind of. This is stud we are using. This is angle channel. Both sometimes they use it. This is channel. Sometimes they also use T. T have been shown or not shown here.
No, now studies which one, that L shape, this one.
This one. This is only yes, by stud gun they try to do the welding directly to the weld. Now we are using 25 dia and which have height of 100 and which have the FC. This is we need to see FC of 149. So if you go here, so connector we are providing on one girder, two connectors or three connectors. We can have a view on our 4 connector we are providing. So we can mention here 4. Ultimate static strength that I have shown you 149. Then they will ask you diameter like 0.025. Overall height 0.1. Center to center. Now there will be 2 spacing. This is longitudinal direction. We can provide 0.25. This will be in transverse direction. We can provide 0.15. Nominal fatigue strength and transverse reinforcement. This you can assume it something. Transverse like in this direction. Length of shear plane. Length of shear plane again 2.5 meter from this point to this point. And now this is should be 0.1.
In code, it is not given us.
Which?
These two, fatigue and transverse line.
No, this is your reinforcement. No? We need to design the slab and get the reinforcement. We can provide it here. Or generally you can put 0.1 code by
Fatigue
code.
strength.
Fatigue, yes, maybe I will have a look. I remember it. QR formula is there. Even if it's not available sometime. Formula is there.
It is there. This one only.
This
sir.
is QR, na? You can see here. For headed start 25 dia, FI3, FU 495. One is for number of cycle you can choose. So I can choose maybe this one 39. So I can directly able to provide in kilonewton. It didn't mention everything code given it. You do not afraid that code is not giving something like
The spacing is what, sir?
there will be stud spacing, na?
No,
You're not
in
seeing-
diagram can you show, sir? This
Ah,
one.
The one will be longitudinal spacing, another one is transverse spacing.
Longitudinal is
here it is mentioned 210. So I have mentioned it 250. Maybe I will change it. This is 210 because 210 is like 200 is your longitudinal reinforcement, so it will be combined with your longitudinal one. That's why it is mentioned 210. And this is your transverse one. Transverse one will be this one. In this direction, this. You will have two kind of spacing. One longitudinal, one transverse.
longitudinal how much, sir?
210, na? It is mentioned here. Same I have been
Okay.
provided. So everything we have provided, so we will just click apply.
Transverse drawing it will not be mentioned, sir.
But
This
transfer
150.
not mentioned, but you can little bit get it by this thing. Like if you come here, 100 have been mentioned. I have provided little no issue. If the 150 is okay, that is also fine. Long transfers now stiffeners will come. You can provide stiffeners also. Web or bearing, like click on this, click web, bearing, click on this, flat, one stiffener, two stiffener. So it will be two stiffeners. So here you can choose flat or T. Now we can also define Fi. So Fi again will be the same. If you remember it, I remember it. 34500. And pitch. Now pitch is important. Pitch we will giving 6 meter. Here B it is asking, it is given 1.15 and thickness I will give 0.012. This I will again going to update. Maybe where is my steel code? I guess
These distances as per drawing, sir. This pitch and this and everything.
no, I have considered the maximum one. You can see here. Yes, it is coming. Okay. And bearing also we will provide it. 3500.
What is the difference, sir? Both stiffness.
I will tell. Bearing stiffness sometimes little bit thicker. Like it will be the part of your end diaphragm, 20 mm thick. Or maybe we can see it. I will show you. Bearing at the bearing location. There will be no
Web
pitching
is
on
at the web location, sir.
at web location. I will see the thickness again to confirm. Like it will look like this, but this is my bearing location. So this is the stiffness. And how much they have mentioned? BS2 plate number have been mentioned. 200 wide they have mentioned. Any other thing? BS3 plate you can easily able to see. BS1, BS2. But they have mentioned here. Some other place might be they have mentioned. If you look at here, then you can see 20 mm. This stiffener is 20 and also this is my end stiffener will be this bearing one. This is also 20 real. So I'll provide this 20. Okay, apply, close this.
another direction is 200, sir.
Width.
But okay.
Here, you can able to see, not in this, but in this drawing. Here it is mentioned at 200 mm. This thing.
Okay, here two stiffeners are connected. So this side one stiffener, this side.
Left and right. Both.
Okay.
Same as shear reinforcement, we consider it. Na? So now this will define transverse stiffener, lateral torsion buckling, yet this will not required because we already provided it. We will click yes. Now here, this is important. Unbraced length again, we will consider the 6 meter.
This is which distance, sir? 6 meters.
The distance between your bracing. The maximum was 6 meter, na?
Okay, bracing spacing, sir.
Yes. Maximum 1. Then we will have the fatigue detail. Now this is the important. Generally, this does not, I need to see unfactor, nominal fatigue strength, unfactor, and uncorrection factor. What do we have? Corrected nominal fatigue. Just one moment. This I need to confirm. I know the value, but still want to show you the backup. Hello, getting my voice? Hello.
Sir.
I have the values, but generally,
In code, we cannot get these things, sir.
in code also. That is what I'm looking. Also, unfactor, nominal fatigue. It is the shear stud. Everything is in the code available. You do not need to go any outside. But just the things are upside down. We need to go sometime up. But not required. Fatigue is the mu. We can mention mu or mu. And this is generally uncorrection factor remain 1. But FF and TF are important. Has anyone seen the SN curve? Known about little bit, because this is very different kind of thing. If I tell you, even not going to understand. These are used for the fatigue strength to get the capacity of steel. Generally for offshore structures, we only use SN curve or API charts. I think if anyone knows about that.
SN curve means this, what will be plotted, sir?
Just name it there, the stresses and the fatigue limits are there according to the number of cycles. We are conceding load, but you will not find a normal thing. This is only used for offshore structure or some steel little bit here. This SN curve, generally all steel design is based for offshore or onshore structures.
Relationship between what and what, sir? Fatigue and cycle.
The fatigue and the stresses according to the number of cycles.
Okay.
Like number of cycle, load will going to applied on this. So I'm looking FF and F. Shear fatigue is means what is this? Uncorrected nominal fatigue. Uncorrected nominal. Design normal and shear fatigue range detail respectively of cycle length. See, this have been mentioned. I know the value, but I'm looking where to get the value. Because I know FDD will be 92 and that is the other one TF will be 67. But I was looking, these are some, according to the weld, there's some how connection should be made. This is SN curve corresponding to cycles. You can see number of stress cycle, uncorrected facilitation. It is here, and correct. Now we need to see for which number
Cycle
of
we have.
cycles. Yes, for 92. Okay, we need to consider the lower one. And for 10 is to power 5. Okay, we will consider this 97 for this point. For the minimum 10 raised to the power 5. Because for bridge, it is not the regarding about the cycle. Generally, this is valid for a lot of steel, not only for bridges. And there will be another one for shear also. Number one for the strength FF have been mentioned.
Both are same, sir.
No, not the same. This is for different things. Something.
Shear stress curve for shear stress.
This is strength have been mentioned here.
No. Figure S7B SN curve for shear stress.
But okay.
Figure name.
But, wait a moment. But in this, why I'm getting it will be around at this one. In 67, you can see. Where is my
What is the
67?
unit, sir? Newton per mm square. What is that?
Newton. Shear is always in the Newton. Stress should be in Newton per mm square.
Here, how we are seeing, sir? Which cycle? How much cycle we are considering for both curves, sir?
Wait a moment.
Like 4 into 10 power 5, or how much we are?
I need to first generally in this we are considering 97. Where is my 100. We are considering 5 is to 10 to the power 6 or 5 around this position. And this should be 97 should be here that I'm looking to find out. Corresponding to I and J Newton per meter. NC. We're considering this line. Can you see here? And also same we are considering in this line. The same position to this.
No, in this direction, sir.
5 into 10 to the power. It is also at this location, but it should be at 97 at this one. That should able to come in. Alpha. Okay. Mu R will be 1, that is fine. Normal shear fatigue strength. Design fatigue and mu R FT1 gamma M naught. FF. We are calculating FF. No? Yes, we are calculating FF. Okay, and If you look at here, we consider it for 5 raised to the power 6 for normal stress range. You can able to see that is when NC is less than this. So we generally consider this condition 5 into 10 to the power 6. So this is coming at this location. This will be at this location. We consider it 97. That's why I remember it 5 into 10 to the power 6. This graph is changing. It will come at this
These values
location.
are what, sir?
For your
180, 40, 40, 45, 50.
lines have been given according to this alpha. You can see here alpha 5. Some alpha have been given. Alpha equal to 3, alpha equal to 5. So here we alpha different. And in this clearly have been given. We consider it directly this.
In the upper
So,
one only we couldn't.
look at there is something, I also not able to use very quiet time. But this is the line we need to consider. You got this thing. This is because 5 into 10 to the power 6 cycle is there. But this value 97 will come. That I also remember it. This will be at this location. At this location, it will be correct. Okay. Okay, just consider it. I know the limit is 97 and this is 97. This is 1. And that was it. 67. So same will be there, 67. And you can select
One is
again
which
the
one, sir?
correlation factor and correction factor. So it will generally remain same. Select, apply. We go again into result, not design. So we have provided fatigue. Now serviceability load combination. For this, again, we need to go into our loads, results, load combination. So here in composite design, if you remember it, I had shown you from where it is starting, from characteristics, from 76, if you need. It is already considered in steel design. I also need to consider. Serviceability in this spreadsheet form. Yeah. You can see the normal form. Characteristics, frequent, quasi-permanent. Okay, put it this. So close this. Let me again go to the design.
Last two
Yeah.
are strength, sir.
Eh?
Last two you have kept strength.
It is last two are the envelope cases. So it's not the issue. Envelope means the serviceability all and strength all. So that is fine. I need to also one thing consider. In loads, what are the characteristics up to which point and from where Now, if you look at here, 76, it is starting. 76 to 126. Then 127 to 185. 127 to 185. One 26. One 85. Now let's see. Fatigue, we have given everything. This do not required. Now first run the model.
In Delhi, rain is there, sir.
Huh?
Rain.
Rain.
Ah,
Yes.
Bangalore is
Rain.
raining heavily. Ah,
Delhi does not have rain. Delhi got the, this back, the summer type of feeling, humidity. Bangalore is good. You have rain on.
no, Bangalore is raining heavily.
So your
Always there will be rain.
roads will be filled with water.
Yes.
Now the model is run. Go to here, design.
After this, Dexlab design is also there in this as well.
No. That slab will be different. Design. It is now same. I choose correct, but why it is not starting? Everything is fine. Something I need to change. Steel code, SRC, concrete beam, concrete color. We have connected everything we have already applied. Design position, interior, longitudinal reinforcement. What is saying? No element can be designed. Already provided IS. That is fine. Okay, I have select the batch design, but SRC, I'm not doing SRC. Analysis. Concrete beam design, concrete beam checking, concrete column checking. Why it is not taking design position? Okay, so that's 14. It is saying no element can be designed. Make sure element section and material types are beam. For properties, reinforcement, everything I have provided complete, time dependent, and then composite girder. Maybe just look, I will look again. This is money. Maybe running this is. Okay, result. Process, doing diagram. We have this. Why do not take it? For system, everything shear connector. Okay, design output position. Hmm. Design output position was missing. Will take some time.
Just check on us, sir.
I have given to it, why still it directly comes like output. Why it is not taking care? I will go back. So output position ij 14. And I will select again all things what I can do if it's not designing. It is rotating but does not giving any output. That is the main concern. So it should, generally it comes here design position ij. Here the element is going. Why it is going, I do not know. Maybe design material, longitudinal reinforcement there, design position. Shear connector I can provide again. Okay, maybe I will do again it. Design position 14. So 149, diameter 0.1, center to center, longitudinal direction 0.1, spacing 0.1, nominal fatigue strength 39. 0.1, 2.5. We are connected, design position, transport stiffness, it is there or not? It is already here. Data Trojan buckling. And the fatigue detail we have also given. Serviceability, load combination we have given. Type of load combination already there. Something is not working in this. Let me check to complete. Do not know what's happening in this. Let it just go. It will work now. Sometimes like this and anything. Field good checking completely. Here I'm not seeing composite one. Is it not success? No sentiment can be designed. Make sure that element, action and materials types are being composite steel, iron, SRC separately. Rebar data. I need to confirm now everything. First of all, I will check the loading results. So this happened with Midas a lot of time, not of all getting this kind of
Design, we are not getting that option, sir.
no, we are getting the option, but it's not doing the design. That is a 15. And even you can see maximum are we getting in the 14th element. Sometime
No, why that option is not available, sir?
option is there. I'm selecting it, but it's not taking any command. I do not know that is IRC22 we are doing, but still
Here what we have to give, sir.
that is what I'm looking. Do we have to give anything or If you're saying no element can be designed, make sure element data correct, rebar correctly, but we have provided everything. Our longitudinal reinforcement, our mid. We have provided everything here. Not like we have not provided.
Properties should be beam something. It's still section and material
That is
types
the thing.
types for beam.
That is the thing only which is causing. I will go into a section mid properties. Maybe I will again update this thing. But it is already I have provided it, but sometimes
This we have provided, but we have to again and again update this, sir.
no. This is first time I'm doing generally. Maybe because of this it is happening or any other reason. I do not know the reason. This is kind of error. Now, whenever I'm clicking, no element can be designed. This is the thing. Something wrong we have done in our modeling or everything comes. No element can be designed. Make sure that element, section, material types are being. Make sure that element, section, and material types are okay. Make sure that element as a beam, section composite steel, material types are SRC. No material type it is shown. Maybe name that this thing. I need to define it like this. Just confirming this theory also.
This material is for which one, sir?
Just checking. I'm not to any other thing. But if this information is correct, then I need, what is this saying? Material data volume cannot be. Man. Getting no.
What, sir?
Wait. It's not. It
Error.
is showing. It is saying your material is not matching with the properties which we.
Full power cut and Bangalore is raining very heavily, sir.
Power cut?
Power cut and Bangalore is raining heavily from 6 o'clock to 10
Okay.
o'clock.
So okay, you have lot of power cut because of rain.
Yes. Daily evening 6 to 10 rain.
So now I think that you're fighting for this water. Something
For
is
what?
going on. I've seen some
Kaveri,
issues was
yeah.
there. Kaveri water.
That is there. That is between Tamil Nadu and Karnataka.
But Bangalore was doing some strikes, no?
Yes, sir.
So,
2 days there was work from home.
okay. You can see here no element can be done. Make sure element, section and material types are beam. Element are beam type, section are steel composite, but it's saying material should be SRC. That is giving little confusion to me.
Material is beam. We are considering steel composite. It is a steel, full steel material, na sir.
One SRC means like this composite.
Steel inside concrete steel is there. Steel reinforced composite means that it.
Yes. So that's what I am trying to do to change structure. Where is my property I have created now? Material it is saying. So then what I need to do? I need to do a lot of things. Time dependent property I need to change. First of all, come here. Then what? Lot of things need to be changed because of this one thing. Maybe that is a thing we are doing. So if I select here and if I go into material and select M40, yes, select this composite information. Okay, it is taking the information. Okay, fine. Okay, got it little bit. Now I have, if you remember this, so this should be go here. This should come.
This SRC is M40, sir. Name.
M40. Close.
For Dexlab, we have done given some M40, no sir. This is also same name.
Here, this will be. Now the main thing will be there. It is calculating, not able to calculate this stiffness. Material, my 2 element is slab. But now it's getting confusing. To him, material is also, if I select element, The number is different from that of other material. Material cannot calculate stiffness. Now it is showing this kind of error. If I run it, it will give the material data of element cannot be determined in the composite section. Whatever assigned to element is different from the other elements. Okay, okay. Then what I need to do?
Entire we
I
have
need
to
to my entire I need to change this. Now say if I run it,
in that CS we have not changed anything as well. Yeah, sir.
yes. Now
In the
something is
construction stage,
yes. What is saying the individual element stiffness will not be formed. Why it is not be forming? Now something is happening to our. If I go to stage 1, this is fine. Okay, if I come here, yes, composite section doesn't cannot be added. Okay, this is causing something. Why it is showing error. Main product is showing something what is telling them some entry static analysis for non-linear iteration construction step 2 stage number 2 static number equation number
some error it is giving us, sir.
yes error is giving and not even telling what kind of error it is. It just tell you something. kind of error it is. The total number of wires, degree of freedom, the individual element structure load matrix will now be formed. Element number 2493 is from 2493. Fine, but due to this composite deform information, okay, I will prove that. Okay. To run and check why it is giving error. I will again try it because seeing it, but do not know why it is calling error. Previously, never done it. So something no element can be designed. Make sure the element vector material types are element is beam, section is composite type. But why this is asking material should be SRC? Okay, no issue. But here this I will solve it. But here everything you got it. Generally, even if you do not have available this data, we can use the also able to design it by the same. Let me show you some 7 by 8 is happening here. I'm not in the code. Then you can
I
design
have
it.
designed using this Midasa, sir.
That is I'm showing it, but you can generally these all formula will be representing there only. But you
No,
will
no,
get
that is okay,
one.
sir. We other anywhere any steel composite design you have done with this same thing, na, sir.
I have done, but I have done 2 years back. That is the thing, the steel component one. So right now they
Okay.
have updated to 2023 or 22. I do not know. Maybe the material
Yes.
I want to change.
Sir.
I will first check it. But this is the same method I follow.
Okay,
SRC
okay.
material means seam bed resistance cement. Sir.
SRC is known as
Sulfur resistance cement.
no, not the sulfur. SRC is like
Steel
composite.
reinforced composite.
Steel reinforced composite. It's the same. Like if you provide in steel, you have a steel tube and you provide concrete in that, and you have concrete slab, you have provided steel in that. Something. Both steel and concrete will be there. Then known as SRC. But SRC we used to design like this. This is SRC. But SRC
Sure, sir.
India, we do not have any code supporting. There is only one SRC code is there. So, but Indian code does not allow it. So that's why I'm little confused. Why it is asking me SRC? Here it is saying element should be beam type. Our element is beam type. Even this is here. Everything is beam. Even this information we have given. Composite span information we have given. Everything is given, and our material section should be composite steel I type. And if you go into the properties, section properties, this is composite steel I type. And then it is saying material. Now the main question is this material. Why it is asking me to choose? Because this is look like this SRC. If you click, it will look like this. Steel, concrete with steel sections. So generally, it does not happen like this. Maybe some Midas is doing some, Midas has some kind of internally intuition. It sometimes does not give, sometimes give. Maybe I will open again laptop and it solves the problem. Midas is like that. It will create problem. It solve automatically. You will not able to know how problem created and how it getting solved. So sometimes Midas have tendency to work on it.
Some old reference file or old designs, whatever you have, you can just check it out and tell tomorrow.
No issues. But I will tell you, this it is asking me this. This is the SRC design.
This is a encased concrete encased steel columns.
This is also all comes in the SRC kind of thing. But generally, we do not design like very easily. And let me show you what I want to show you. This comes in moment factor. Buckling. This is buckling. I will give you, but generally we need to check. So I'm looking if that formula in this code have been mentioned, or then again we need to refer IRC 24. So IRC 24 is fine. This is just moment of resistance diagram. Like if you remember it in the concrete, here in neutral axis lie within the slab generally. So our diagram look like this in plastic zone. So this is not the elastic zone. Elastic zone it will be there, so it will be rectangular, triangular type, not rectangular. So you can see B effective again will come here. Again, same, nothing else. So MP, okay, here will be one. What is I'm looking here to give you plastic neutral axis. This is the property they are calculating. But property, what I was looking here. We divide the B effective wherever it has been mentioned. There is one more thing. After becoming composite, your effective width changes. It will
This
become
neutral axis, how it will be, sir? Before composite, after composite, where it will be, sir? It will be changing.
it is changing now because of this B effective. That is what I'm looking. I want to show you. That will clear your doubt. Here I'm looking that thing because this B effective will going to change after composite. Before composite, it will be fine, but after composite, it depends on to SIDL. For dead load, it will be fine for self-hit, but for SIDL and for live load, it's going to be change. That's what I'm looking. Non composite section negative moment. The formula same is there, that P Fi upon gamma m. Where is that formula for effective width? Flange, construction stage where our steel will be there. And we do not have any concrete over it. But where is that main formula? Generally, I will explain, but I'm looking, maybe I can give you the from the code itself. Material properties. Nothing they are giving. Okay, I will explain to you. What generally happen in a steel design. So normal steel design, you have already seen that normal does not have any kind of issue. Like if you have any kind of section, I section, a C section, angle section, or T section, angle T, or then you have tubes, rectangular hollow tube, square hollow sections, then you have circular hollow sections. So these are steel section, different. But in this, all section can be built up section. Some all section can become directly hot rolled, and they can also make built up section. So what is meant by built up and hot rolled section? Built up section means different plates you are going to attach with the welding and create one section. And what is mean by hot roll? They will be directly molded in accurate I shape, C shape, L, this angle shape, T shape. So that is mean by hot roll. So whatever you choose, we require properties like moment of inertia, section modulus. So those are the important properties you need to calculate. Now in steel bridge, what will happen? First of all, our steel girder will be going to be casted like this. We do not have any slab, and they will be rested here, and we will have some, maybe you can say stiffeners are here, like this is mid, this is stiffener, this is end bearing stiffeners, these two, and these are mid, maybe all over along the length, normal stiffness. So this is the one. Now you will cast this thing.
Ours is built up type of section only, na sir?
In bridges generally built up. So now we casting slab. Okay. Now slab have been casted. Due to slab, there will be self weight of steel also, and slab green concrete weight. So we need to check our steel for only self weight and concrete weight. That will be simple formula, that MP equal to ZP section modulus into Fi upon gamma m. So this is my moment capacity. I can directly check. There is one formula for shear capacity also, or axial capacity. Both, everything shear, even the axial capacity give, like if I remember, axial capacity will be, it will be area of your girder, area into Fi divided by gamma m. You will have axial capacity, then there will be shear capacity, or maybe another minor axis. This will be the major axis, like if you are calculating MPZ, then there will be MPY, and we need to combine this all, and it should be less than 1. So this is normal design for a steel girder for all over the steel. This can be valid, but there is some extra check will come, like lateral torsion buckling due to the thinner web. Only some conditions are there. Those just we need to fill the formula, nothing else is there for steel. But now when it becomes composite, because we know this concrete will going to be hardened, and we already provide studs here. So now what will happen, that is what I am trying to tell you. Now there will be effective width like this. Then and where is my other color? We haven't mentioned that. And here is my steel. Little bit at this position.
So for that capacity check, shear will not be included, na sir.
No, not necessary. Shear check will be only through the web.
Only this axial and bending.
Axial and bending, yes. Shear does not come in combined check. Because shear depends onto your web, not flanges or full area.
Shear and torsion, that is in web and
Different. Torsion you can resist by stiffeners and bracing. And even the top slab provide the torsion resistance. But shear is just straightforward. We check for web only. Now it will become composite. Now what will happen when it is becoming composite? There are n number of load going to act. First load, self weight of concrete at high steel girder. So this load should be resisted by the whole property. Like whatever the width I am getting, this is the effective width. Maybe this number. So this is BE effective. So like if my distance is 2.5, so it will remain 2.5 meter, and I will have neutral axis generally lie above my steel girder about at this position or at this position when I'm considering 2.5. Okay, now another step is this. This 2.5 will be divided by some number, like there is one modular ratio. This will be divided by modular ratio. What is modular ratio? EC upon EC, ES upon EC. Modulus of elasticity of steel upon modulus of concrete. But why we divide it? When we check for SIDL. SIDL means your this loads, superimposed dead load, which will be due to your crash barrier and due to your this slab. Sometimes we also include the this slab weight and also one more bearing code. So for this, we divide by modular ratio or by 15 for SIDL. This 2.5. So it will only remain if you divide 2.5. All formula remains same. Nothing will going to change. So how much? 0.333, like 300 mm. Very less, but it will still again going to look like, if I make the diagram, like it is very small. Then you will have a steel girder like this. Again, same location. But your neutral axis now going to be shifted at this location. It will come around at this location. So your property is going to be updated. Then again, we need to check our steel, this girder, and this concrete will behave as a steel. So this we need to find out again properties of this concrete plus steel as a considering as a steel. Like it will whole thing will behave as a steel. We will get again this thing section modulus, and this moment of inertia and everything. Then we will check again our capacity and our forces and everything again by same. This is for SIDL. For SIDL, divide by 15, or if modular ratio is higher, then, but generally 15 is always the higher. Then if you go for live load comes into your transition load. Then again, we need to divide our effective width by 7.5.
This code is giving something, or based on what we are dividing?
This is code has given, that is what I'm finding out, not able to find out the accuracy, but code has given this all. So this again we need to calculate properties, then again we need to do a checking. So that's why in steel you need to find out 4 times the properties. First without any concrete slab, with concrete slab, then for ISIDL divided by 15, for live load divided by 7.5. Then again, everything need to be checked, every clause need to be confirmed. That is the steel main design for composite one. So that is the theory and you can say the design behind it. So that same thing that is what I am trying to do here while applying all those things, but it is not taking. Maybe I will restart and have a look. It will solve or not. So the main thing is about the design is this: our steel property is going to be changed throughout the design. It is not like a concrete which will remain same throughout the end. Steel changes as we move further. First, steel does not have anything, then concrete come, then concrete, what is known as we transform. This is known as transform section. This is transformed into steel.
So first
Okay,
individually steel girders properties. After that, for transform section, we will calculate the properties of it.
yes.
We are converting the concrete into steel.
To
Master.
steel. Yes, that is known as transform.
For converting that concrete into steel only, this modular ratio we are using.
Yes. Not modular ratio. We have limit 15. Whichever is higher, we have to use it.
No, this modular ratio we have to use in converting that steel to concrete. Concrete to steel means in property calculation we have to use, or just we have to divide in the effective width only. Yes.
Only effective bit. Only effective bit. Only effective bit. Okay. Nothing else. By dividing effective bits, it will automatically will convert.
It will be converted into a steel
Transform.
type.
Transform section. You can go ahead. Okay. So I will try to solve it. So in next class, we will discuss about the truss or other steel bridges, how they design it, or what is the main, how arrangement will look like. Okay.
Okay, sir.
But remember that the commands are all correct, but I do not know what is happening.
And show some steels, this designed report.
I will show you.
What are the checks we have to do? How
yes.
they will be designing it.
Okay.
Other in Midas design report also.
Okay. Got it.
Old file, whatever you will have, na sir.
Sure.
In that, what are the checks we have to do? How we will be checking it? What we will be doing? All this. Okay, na sir.
Sure.
Okay. Sir.
Okay. Bye.